So we have done up to the critical angle and the fish seeing the outer world.
Yes, sir.
Isn't it? Let us try to
Yes,
talk
sir.
fastly. Refractionality of plane surfaces. Okay.
Yes.
Refraction on a plane surface. Very, very important bit. Refraction on a plane surface. Okay. That is concept of real depth and apparent depth. Concept of real depth and apparent depth.
Apparent depth.
Apparent depth ante manaku kanipistundi. We are assuming.
Yes, sir.
For example, if a 5
We
rupee
think it is there, but actually it is more deep.
and if a 5 rupee coin is being placed in a beaker, and if we see it from outer side, what happens? It appears to be a little bit raised together.
Yes, sir. It looks big.
Yeah, so such type of your conditions is called as of your apparent depth.
Apparent.
Okay, like say for example,
Yes.
this is some vessel. Okay, and in this one, water is being filled. Say for example, water is being filled up to the upper part like this.
Yes.
Like a lake. Okay.
Yes.
And there is a normal here somewhere. Say for example, this is your normal. The fish is seeing an outer world. Like say for example, if object is being kept at the lower block, a 5 rupee coin is being kept here.
Yes.
If I take a ray diagram for this one, a ray of light from this object will be incidenting on the surface like this.
Yes.
Again, if I'm drawing a normal for this one, this will be the normal beta somewhere here. Okay.
Yes, sir.
This object is seen from where beta? The ray of light is being seen from the outer world. If I'm standing somewhere here, and I'm trying to see this coin, for me it appears the ray of light is coming from which medium beta? Denser medium, kada?
Yes, sir. Denser to rarer. So it will move away.
So obviously this
away
one
from the
angle of your incidence side. This one is your normal. This one is also your normal. And you know that
yes.
ray of light will bend away from the normal.
Yes, sir.
So this is where somewhere I will be seeing. So if I extend this one in the backward direction, I am able to see this object somewhere here right now. Okay, na?
Okay. Yes, sir. Yes, sir.
The ray diagram.
Yes, sir. Got it.
This is the angle of refraction. That is nothing but R.
Yes.
So this is the object. This will be what beta? Image. This will be what? Image. That means I'm able to see the image of that one. It is slightly raised above. Part of a lesion.
Raised.
Now actual depth of this one is nothing but equal to, say for example, D. From here to here, this represents me that D is nothing but what? Real depth.
Yes.
Real depth of the object is nothing but a VD. But for me, it is appearing to be raised. So this distance is known as of your apparent depth. So this distance is known as what for me? Apparent depth.
Apparent.
This distance is known as what? Apparent depth. And from here to here, this is nothing but what? Shift in the image. Shift in the image that I'm representing it by your S. Is that clear? Any doubt in this one?
No, sir.
Doubt in this one? This is object.
So shift is the difference between the real depth image and the apparent depth.
Well, if I need to do the difference of real depth minus apparent depth.
Apparent depth. Yes, sir.
The real depth is D. Apparent depth, I'm taking it by, like, say, for example, some T.
Okay, sir. So D minus.
So you are seeing in the air kabatti, this is the refractive index of your rarer medium. This is the refractive index of your denser medium. That is nothing but of your mu D.
Yes.
Avana?
Yes.
This is the refractive index of denser medium. So what is your real depth beta here? I'm writing in detail, you see right now. Real depth is equals to The real depth is represented by D, or we represented by T also, no problem. Apparent depth will be equal to your apparent depth is equals to how much for me? T uncle. We're assuming it.
T.
Okay. Now theta is very,
Yes.
very small beta. Angle of your incidence, whatever you're taking, it is very, very small. If this is R, you know that this one is also be equal to R beta. If I'm extending this
Yes, sir. That is also R.
with the normal, that is also making an angle of your R part deflection. As we know
Yes.
that theta is very small. As theta is very, very small, we'll be writing sine theta is approximated to what beta? Tan theta. I told you this one in basic mathematics. If the theta is
Yes, sir.
2 degree or 3 degree, we take sine theta is equal to how much beta? Tan theta.
Tan theta.
Now from the given figure, write the value of tan I. Tan I is equal to how much? Which side by which side? This is point A. This one is, say, I'm taking it as of your point B, and this one is O. From the triangle AOB, this one is right now this triangle.
A,
ABO.
O, B. Sir,
Tan I is equals to
sin I
tan I is,
opposite by hypotenuse.
yeah. Opposite is what? Tan theta kada. Why
Yes,
hypotenuse?
sir.
Vertical by horizontal kada. Tan
Yes,
theta.
sir.
That means it will
No,
be,
sir. I'm telling sin theta.
yeah,
Sin theta.
because it's same kada. Sin theta and cos theta. Tan theta is small, na?
Yes, sir.
So it will be
Yes.
B divided by your AB divided by your AO. Antena?
Yes, sir.
There, this is your triangle.
AB. Yeah, opposite by adjacent.
Yeah. This one is your,
AB divided by.
this is your,
Yes, sir. Got.
this is your B, and this is your O. This is your depth. There is nothing but of your real depth, and this is your what? Some distance x part deflation, what 8 by 5. Say for example, some x, and this will be the hypotenuse.
Yes, sir. Got it. Sir.
Now tan theta is equals to how much for me? Tan theta is equals to your AB by your AO. AB I don't know, so I'll keep
Yes, sir.
AB as it is, or I'll keep it as x. A to O is what better? D. A to B is nothing but.
Yes, sir.
That means I can ultimately write tan I is equals to AB. I have given a word x divided by D. Can I write like this?
Yes, sir.
This is your tan I. The same way tan R if I am writing. See the triangle right now from the tan R. This one is also your R. This one is your I.
Yes, sir.
This is your A, and this one is B. This is your X, and this one is nothing but of your thickness. That is
Same,
nothing.
sir. X by T, sir.
How to write beta? So tan
X by T, sir.
is equals to, again we'll be writing that one as equals to AB divided by AI.
Yes, sir.
Pseudo diagram. See the diagram?
Yes, sir. Got it, sir.
AB divided by AI. AI is nothing but equal to how much for me? This will be your X by your thickness T.
Yes, sir. X by T.
Number 1, and this is my equation number 2. Apply
Yes, sir.
Snell's law. Applying Snell's law, two rays must be very much closer to normal beta. Then only I can say that B and A will be very, very small. That means
Okay, sir.
very, very small. If A and B distance is nothing but smaller only. Now, like if it is 1 degree, 2 degree, then A and B are like somewhere very here right now. Basically, if it is like 2 degree or 3
Okay,
degree,
sir.
isn't it? A and B are almost all coinciding.
Yes, sir.
Isn't it? So if I am applying the Snell's law, what is the Snell's law formula? You tell me. So it is nothing but of
Mu sin theta is equals to constant, or mu 1 sin I
sine of
is
your
equals to mu 2 sin R.
equal to mu R into your sine of your R.
Yes, sir. Mu 2 sin R.
Where is the refraction is happening here, beta? Refraction is happening in the rarer medium.
Yes, sir.
Refraction is in the rarer medium, mu R. Isn't it?
Yes, sir.
From denser medium kabatti, mu 1 is nothing but here I can write as of your mu D. Denser medium kabatti.
Okay, sir.
Isn't it? Now that is the relation.
Yes, sir. Mu of dense.
Clear?
Yes, sir.
As angle of incidence and angle of refractions are very small. So I told you that sin I will be equal to what? Tan I. And sin R will be equal to your tan R. Okay,
yes, sir.
So I can write this one as of your mu D is equals to your as angles are very small, I can write here as angles are very small, I can write mu d into your tan of your I is equals to your mu rarer medium into your tan of your R. So I can write refractive index mu d into tan I. Tan I value enta chudu. So tan I is equals to x by d. So I can write this
Yes,
one
sir. X by D.
x divided by d. It is equals to refractive index of rarer medium. This is x divided by
X by T.
this one and this one will get right now cancelled there beta. So I can write here right now refractive index
Yes,
of
sir.
denser medium divided by refractive index of rarer medium is equals to d by t,
Yes, sir.
isn't it? So that means what? That means what? Refractive index, whatever you are taking right now for this relation, refractive index will be equal to how much? Refractive index will be equal to rarer medium enta. You can be writing this one as
Okay.
refractive index of d by your r beta. That is equals to
Yes, sir.
but what real depth? I can write this one as of your real depth,
Sir, so it's real depth by apparent depth, right, sir, basically.
apparent depth. Like fish seeing an outer world. Like fish seeing
Yes, sir.
the outer world. Refractive index of air will be equal to 1, isn't it? If refractive index of air is equals to 1 and refractive index of denser medium, I'm taking it as mu. So can I write
Okay,
the
sir.
formula as what beta? So mu r you take 1, mu d we take it as mu. So this will become for me basic formula. Mu
Sir, the denser medium, the denser medium, we can take it as water, right, sir?
water we can take.
So, ante value will get, right, sir?
Water is cold. If it is a light in a swimming pool, it can be anything either.
Okay, okay. Like
Isn't it?
that, yes.
Refractive index of the denser medium, if I am assuming as of your mu, this will become for me what beta formula? Real depth divided by apparent depth. Real depth divided by your apparent
Apparent depth.
depth. Is it clear?
Yes, sir.
Nothing but d divided by your thickness t. This is your formula.
Yes, sir.
What is the condition? When object is in the denser medium and you are leaving it from outer bowl. That means a fish seeing the bird.
Yes, sir.
Sorry, a bird seeing the fish. When a bird
It'll
is,
look at it a bit.
isn't it? Like say, object is in denser medium and we are weaving it from the rarer medium. Isn't it? This is a condition where object is in which medium beta? First case, object is in the denser medium, case number 1. This is a case number 1 where we have written in this one, object is in denser medium. Object is in denser medium and weaved from rarer medium and weaved from rarer medium and weaved from your rarer medium. Is it clear? Object is in
Yes, sir.
medium and we are weaving it from your rarer medium part of relation. In that cases, if I can write that one, so that will be the basic condition. Clear?
Yes, sir.
So what is the condition? When object is in the denser medium and weaved from the rarer medium, it appears to be nearer or farther, like a bird seeing the fish.
Sir, it actually,
Nearer
we
or
can
far?
see it closer, sir.
Yeah, isn't it?
It is
So,
actually far.
so when a bird is seeing the object, like a sea, when a bird is seeing a fish, it appears to be raised. It appears to be raised or it appears to be nearer.
Yes, sir. Yes, sir.
Yeah. So object was
Clear, sir.
medium and it is seen from the rarer medium part of relation. Now tell me what will be the basic condition right now? I have got everything right now here. So shift will be equal to how much in this case? Shift will be equal to real depth minus apparent depth kada?
Yes, sir. D minus T.
So what for me? Real depth minus apparent depth. So shift will be equal to how much for me?
D
D
minus T, sir.
of your T,
Yes, sir.
isn't it? Now what I can write the value of your D beta? Or T value I can write in terms of D by mu.
Yes, sir.
So this will be equal to D minus thickness will be equal to D by mu, can I write? So in this one, D will be common into 1 minus of 1 by mu. So this will be the shift form.
Okay, sir.
So shift will be equal to how much? Shift will be equal to your real depth into 1 minus refractive index. D is nothing but what here? D is
D
real
into
depth. D is equal real depth is your real depth, mu is your refractive index.
Yes, sir.
Any doubt in this one?
No, sir.
Clear?
Clear, sir.
So when the object is in denser medium and viewed from the rarer medium, it appears to be raised. How much it has been raised until this will be the formula. That is S is equals to how much for me? D into
1.
1 by mu.
Yes, sir. T into 1 minus 1 by mu.
Is that clear?
Yes, sir. Clear, sir.
Isn't it? So that is our basic condition. That is refractive mu is nothing but what better? Refractive index of medium hai kada?
Yes, sir.
Refractive index of medium. Medium
Medium.
is nothing but water. Is it?
Yes, sir.
Okay, na?
Yes, sir.
So that is our first condition you need to remember in this one. In the opposite case of that one, beta, that means when the object is in the rarer medium. Next one. Object is in a rarer medium. Like bird. Object is in the rarer medium and is seen from denser medium. And is seen from your denser medium. Do you know the swimming?
Yes, sir.
Isn't it? So from the water, if you see any object outside, it appears to be nearer, it appears to be far. You try to check it out once there.
Okay, sir.
Okay. If an object is in medium and it is seen from the denser medium, normally
Sir, it appears to be farer, sir.
it will appear for me farer. It appears for me farer part of relation. So object is in denser medium and seen from the denser medium part. Normally means straight vertically up. Normally
Yes, sir.
through plane faces. Normally through the plane surfaces, it will appear further. It will appear far away.
Yes, sir.
It will appear far away. Is the condition clear?
Yes, sir.
For me, far away. Object is in the rarer medium and it is seen from the denser medium part of relation. I hope you are clear this one. So now I'm writing
Yes,
that
sir.
you see right now. So if I'm taking the diagram, same like a previous case. Now this is again the same condition. Sorry. This is the norm. Okay. That is your norm.
Yes, sir.
It is filled with the water here, right? Okay. Now see, for example, there is a fish somewhere in the bottom. Like say, for example, if I'm taking an what do you call that one object part of relation, this is your denser medium. Like say, if this is a bird, beta. Like say, a bird is somewhere here. Okay.
Yes.
This is your bird. So some bird is present here like this. So this is what beta. This from the surface. From the surface, this is your real depth.
Yes, sir.
Depth. That is nothing but that is from real depth D. Okay, na?
Yes, sir.
The fish is somewhere here. Okay, and this fish is seeing this bird. Okay.
Yes, sir.
What happens when the fish is seeing the bird right now? The ray of light. You know that the ray of light, when it is coming from the rarer medium to denser medium, generally it bends towards the normal.
Yes, sir. Towards rare to denser.
If I'm taking the ray diagram for this, the ray of light in this one will be somewhat like this. The moment it is entering
Yes, sir.
from rarer medium to denser medium, like say this is a given condition when a ray of light has been incident here right now like this. The moment it enters into the denser medium, what happened? Slightly bend.
Sir, it'll move towards the normal, sir.
This is your normal for this one. I've got Rajesh. This is a given condition. It bends towards the normal. It bends towards the normal. It bends towards the normal right now like this.
Yes, sir.
isn't it? Now this bird, when it is seeing the fish, so this will be the angle of incidence I, and this will be
Yes, sir.
angle of refraction, that is nothing but R. Okay, now if I
Yes,
extend
sir.
this is the angle of your incidence, that is nothing but double arrow mark, and this is one single arrow mark. From the eye, if the bird is seeing this fish, what happens? If the fish is seeing this bird, what happens? If I extend this one in the backward direction, the ray is meeting somewhere here. Ravga. If this is the,
Yes, sir.
it appears to be somewhere here right now. So this will be equal to
It's
your how much?
actually,
Here it will be shift.
yes, sir.
From here to here, this will be your apparent depth.
D. Yes, sir.
Apparent depth. That is nothing but d dash and column.
Okay, sir.
Okay, that means for the fish,
Yes, sir.
I'm seeing it. The fish is seeing that bird outer side. That is the reason the fish will, like kingfisher birds, whatever they are able to eat the fish's kabati. When though they are very nearer to the surface, for the fish it appears it is very far. That is the reason they are swimming in the upper surface so that they can be catchable very easily.
Okay, sir.
What am here? Refractive index.
Yes, sir.
This one is say for example mu. Refractive index for the air will take it as 1. Refractive index of medium will take it as mu. Clear? Any doubt?
No, sir.
The object is where beta? In the rarer medium. Object is in rarer medium and seen in the denser medium.
Viewer in the, yes, sir.
Yeah. Applying
Yes, sir.
Snell's law. Again, same condition. Angle is very, very small. Applying your Snell's law, that is your mu1 into your sine I is equals to mu2 into your sine R. Mu1 is nothing but what? Refractive index of air. This one is your sine I, that is equals to refractive index of denser medium, that is nothing mu d into your sine of your R. Clear?
Yes, sir.
Refractive index of air is how much, better I told you? Refractive index of air is 1, and this one will be equal to sine into I. Refractive index of denser medium or medium, I'll be taking as
Sir, your voice was breaking, sir, actually.
I know. Voice break out of that.
అవును, sir.
Okay, fine. Improve.
Now it's okay, sir.
Now tell me, as angles are very small, as
Sin theta is sin I is equals to tan.
very small, I can write sin I is equals to how much better? Tan I. So tan I
Tan I,
is
sir.
equals to mu into
Yes, sir.
tan R, isn't it?
Yes, sir.
Tan I from the given figure, you tell me. Where is tan I right now here? So this is the surface in Kundam right now. So this is say for example some point P. Okay, and this is some point,
Yes, sir.
for example A. So tan I is equals to how much?
Opposite by adjacent, sir.
So it will be your AP divided
AO,
by your PO.
sir, AO divided by AP, right, sir?
Huh? Tan I,
Sorry, okay, yes, sir. Opposite, yes, sir. Got it, sir.
this is your I, na? This,
Yes, sir. Opposite is AP by,
and this is your object.
yes, sir.
It will be your AP divided by PO. Can I write like that?
Yes, sir.
Divided by your AO is equals to your mu into tan R will be equal to how much? Tan R is equals to, if this is R, this is also your R gada. Sorry. This one is also R gada.
Sir, is it AP divided by,
AP divided by,
it's AP divided by OP, right, sir?
yeah, PO, sorry. I have written. This is your,
Yes, sir.
okay. The same way, one more
Yes, sir.
we are getting like this. This is image gada. So this one is right now for my example image, and this one is nothing but P, and this one is nothing but your A, and this one is nothing but equal to your R. So this will be equal to how much beta? AP divided by your PI.
Yes, sir.
AP divided by your PI. Isn't
Yes,
it?
sir.
Anything is getting cancelled in this AP and this AP will get,
AP. Yes, sir.
it is 1 by PO. P2O is nothing but what beta? Real depth.
Yes, sir.
Real depth, I'm representing it by D. That is equals to mu divided by, this will be equal to your apparent depth.
Okay, sir.
Apparent depth is represented by D dash. Okay, so therefore I can write here now mu is equals to how much beta? Mu is equals to what I can write, can I tell you? So mu is equals to apparent depth divided by real depth.
Yes, sir.
Apparent depth divided by real depth. That is equals to your
It's opposite over here.
divided by. Is it clear?
Akkada condition lo it is opposite, right, sir?
That's it. So
Real by apparent, here it is apparent by real.
mu will be equal to your what beta? Mu is equals to apparent depth divided by real depth. Or else I can write
Real
apparent
depth. Yes,
depth
sir.
will be equal to mu times of your real depth.
Yes, sir. That also.
Can you tell me what will be the shift? Shift will be equal to S here. So shift will be equal to
D
what?
minus D
Apparent
dash minus.
depth, apparent depth minus real depth,
Yes, sir.
isn't it? See the diagram? See the diagram? Yes, I need. So it is pi divided pi.
Apparent is. Yes, sir. D dash divided by
So how much I'm getting is
D
it?
dash divided by D.
Apparent depth is how much beta?
D dash, sir.
Yeah, it is d dash minus of your d.
D.
Dash is
Yes, sir.
mu into d minus of d. That means this will be
Yes, sir.
mu minus 1 into your d.
Okay, sir.
The shift is here.
There it is D into 1 minus 1 by mu, and
Yeah,
here it is mu minus I by
exactly.
mu minus I into D. Yes, sir.
How can this one?
Yes, sir. Got it, sir.
So it's closing the here, beta.
Yes, sir. Clear, sir.
So when object is in denser medium, and image is in the rarer medium.
Tensor to rarer. Sir, it'll move away, and we see it in farther than actual.
Then
Yes, sir.
the relations.
Yes, sir.
For multiple slabs also you can use the same relation. Beta.
Okay, sir.
Slabs also if I'm taking, we can be using the same rules for the related work one. See this question. See this question. If fish is rising
Yes, sir.
vertically, fish is rising vertically to the surface of water. To the surface of water. To the surface of water in a lake. In a lake. Very good question, but I will get this question shortly in this weekend examination also. Okay.
Okay, sir.
To the surface of water in a lake uniformly at the rate of 3 meter per second. Okay.
Yes, sir.
Observes a kingfisher. Observes a
Bird.
fisher bird
So denser to rarer here.
which is diving vertically. Is diving vertically towards the surface of water.
Yes, sir.
Towards the water at the rate of 9 meter per second. At the rate of 9 meter per second. Vertically above. Vertically above. Okay.
Yes, sir.
If the refractive index, of water, refractive index of water is 4 by 3.
Yes, sir.
Find the actual velocity, of the dive of bird. Dive of the bird. Who is singing good? You tell me first that part.
Sir, the first is
Fish is rising
means
up to the surface of water. Another.
yes, sir.
And uniformly at the rate of what? 3 meter per second. And in the
Yes, sir.
observing, a bird is diving vertically towards the water at the rate of 9 meter per second.
Yes, sir.
Both of
Even that is
fish is moving with 3 meter per second, bird is moving with 9 meter per second.
yes, sir.
So bird is in denser medium, bird is in rarer medium, fish is
Rarer medium. Yes, sir.
so, and refracted index
Air
of
and water.
that is given 4 by 3. Now, what is the actual velocity of the diving of bird? That means if the fish is seeing the bird, it appears to be far kada. Anna? Is it clear? Hello? Hello?